The environmental complex of Cerceda is located in the north of Galicia, in the inland of the province of A Coruña. It belongs to Sogama, which means Galician Environmental Society, a company with 51% of the shares owned by the Xunta de Galicia and 49% by Gas Natural Group, a multinational leader in the electricity industry in Spain. The task of the complex, which takes up 65 hectares, is to process the urban waste of the 296 councils attached to this entity, almost covering the whole region of Galicia. The treatment process starts very far from here, in each house, separating waste in categories. 2 of these fractions of waste will arrive in Sogama, what we call yellow bag and black bag. This first separation is very important. Thus, Sogama carries out initiatives to educate and raise public awareness. The yellow bag is that from the yellow container. It contains receptacles, packaging, bottling and plastic jars, canning from food and drink, both made of aluminium and steel, cartons and polystyrene trays. The black bag contains all the waste that does not go in the yellow bag and has no specific collection. Mainly organic waste and non-recyclable waste, sanitary napkins, diapers, worn clothing. The collection process is the responsibility of each council, and then the waste is centralized into 37 transfer facilities, strategically distributed all over the region. The role of these transfer facilities is to enhance the transfer of waste from the council collection trucks to containers with greater capacity, up to 20 tons, and more appropriate for long-distance transportation. In these facilities, waste is not processed in any way. These closed warehouses avoid noise emissions, have air suction and filtration systems to prevent dust and odor emissions, and also have a water treatment system. The containers are completely closed and especially designed for waste transport, guaranteeing the best hygienic and safety conditions during transportation. As an additional support for energetic efficiency, Sogama managed to receive 45% of the containers by train, the lower environmental impact transport means. This is a great achievement in a region with the orographic and demographic features of Galicia. When the containers arrive, their weight is controlled by a scale and they are unloaded in hoppers. The material from the yellow container goes to the automated light package classification plant. It has a total surface of 5,000 meters squared and processes 6.2 tons of waste per hour, using automatic systems that enhance it to reach a selection capacity that is faster and much higher than any manual classification plant. Waste first goes through a filter where the items are distributed by size into 4 main categories. Those items are centrifuged in a trommel with a drill drum where receptacles are filtered by size. The different kinds of receptacles are separated considering if they are flat or rolling, that is lighter or heavier. Once they are classified, they pass on to new filters. At the same time, a strong electromagnet extracts ferric fractions. Garbage bags and plastic packaging are collected by huge vacuums. During this process, paper and cardboards are also separated, as this type of waste should not be disposed in the yellow waste container. In the classification circuit, the material in movement is then classified in 2 categories: plastic and non-plastic materials. An optical reader selects and separates cartons from the other materials. With a Foucault separator, the aluminium fraction of waste is separated. Right after that, waste goes to a sort room where the quality of the selection is checked. Lightweight or flat receptacles are again classified using an optical reader that immediately identifies the items that should be separated. They move along the conveyor belt at a speed of 11.5 kilometers per hour. The items are sorted considering if it's PET, polyethylene terephthalate, or PEAD, high-density polyethylene or hard plastic. All the other plastics are recovered in a mixture. The leftovers of cartons are extracted from non-plastic materials using another optical reader, and those items rejected by the automated light package classification plant are conducted to the fuel fabrication plant. The selected materials, sorted according to its composition, are packed up to be sent to their corresponding specific recycling centres, where they will be used as raw materials for new products. At all times, the circuit of the automated light package classification plant is inspected by qualified operators who check the quality of the material selection. On the other hand, the black bag and the discarded materials of the automated light package classification plant are transported to the recycling, treatment and fuel fabrication plant. The objective of this plant is the production of RDF, refuse-derived fuel, using non-recyclable waste. Urban waste is unloaded in 2 ditches with capacity for 5,000 cubic meters. From there, a bridge crane transports the waste to hoppers that feed 2 pre-treatment lines. There is always a 3rd line available to start working in case one of the other 2 lines needs to be stopped for technical or maintenance reasons. Waste is introduced in trommels where the bags are opened and the material is separated in 2 fractions according to size. That is, in fractions greater or smaller than 12 centimeters. The fraction of bigger material is shred in grinders with blades to reduce its size, and the fraction of smaller material is dried to reduce humidity. During both processes, there are mechanical systems like overbands and Foucault currents that enhance the separation of steel and aluminium so that they can be sent to the recycling centres. The thin material is moved to drying rooms where the current of hot gases from the cogeneration plant dry it until it reaches the 30% of humidity. When the material is dry, secondary trommels separate it into 2 fractions. One of them bigger than 40 millimeters and the other one smaller than 40 millimeters. This classification intends to extract all those inert fragments that the RDF might carry later, like glass, stones, remains of ceramics, etc. This separation is made by densimetric tables. Drying steam is purified by gas cleaning cyclones and towers before going back to the atmosphere. The 3 fractions according to size, big, small and very small, are mixed together after each of their processes, creating what is called refuse-derived fuel, RDF, that will feed the boilers of the thermal power station, TPS. The thermal power station has 2 boilers with fluidized circulating bed, where fluidized sand at high temperature comes into contact with the RDF to enhance high-efficiency combustion. The flue gases of the furnace heat the steam circulating through the pipes that compose the superheater packages of the boiler. There, steam reaches the appropriate temperature to move a turbine that moves an alternator to produce electric energy, approximately 50 megawatts. The furnace keeps temperature higher than 850 degrees C and has 6% of oxygen to guarantee the destruction of dioxins and furans. The steam coming out of the turbine cools in a condenser with a capacity of 162 tons per hour. Water cools through 5 forced draft towers. This condensed water is sucked by 3 condensate pumps that bring it to a deaerator, and then it is accumulated. The gas produced by the combustion of the boilers travels through a system of semi-dry treatment with addition of hydrated lime and active coal for its purification. The neutralization of the contaminating compounds takes place in a reactor, and then they are retained in the filters of the hoses. The cycle of energy production closes with the collection of the waste of the furnace, which is divided in 2 types, dross and ash. The dross is stored in a garbage dump together with the inert material separated at the fuel fabrication plant. Most of this material is glass, stone or ceramic. On the other hand, the ash produced by combustion is classified by law as toxic waste, so it is stored in 1-ton protective waterproof sacks. These sacks are kept in a controlled warehouse. The possible reuse of dross in the construction industry to substitute the conventional aggregate is being studied, as it would lead to a more sustainable and environmentally friendly construction. Another important building of the environmental complex of Cerceda is the cogeneration plant. It has a double task. On the one hand, it produces electric energy, and on the other, as we mentioned before, the residual heat of the flue gases is used in the rotating dryers of the recycling, treatment and fuel fabrication plant. The cogeneration plant has 6 electricity generator engines fed by natural gas and able to produce up to 22 megawatts. Among the auxiliary facilities of the environmental complex of Cerceda, the RDF warehouse is particularly relevant, and it is placed between the fuel fabrication plant and the thermal power station. The refuse-derived fuel warehouse is a diaphanous space which is 250 meters long, 50 meters wide and 12 meters high. There, the RDF is stored waiting to be required by the thermal power station. It has enough capacity to store the RDF produced at the fuel fabrication plant during 8 days. The environmental complex has strong environmental protection measures to ensure compliance with the applicable law, meeting the most rigorous requirements of the industrial sector. This complex has advanced systems of gas purification and temperature conditioning that treat the gas with chemical vacuum through a reactor with lime addition, active coal and hose filter. Water treatment is also a special concern, so water is treated with a biological and physiochemical process of coagulation flocculation. Sewage water is stored and treated in large basins. To guarantee the compliance with this strict law by FAR, this complex includes a chemical analysis laboratory to permanently control the industrial process, and independent controls are carried out to safeguard environmental quality parameters at all times. The activity of the environmental complex of Cerceda is complemented by the controlled rubbish tip of Ariosa. As the waste received by this company exceeds the treatment capacity of the complex, it can process a maximum of 550,000 tonnes, and more than 800,000 tonnes are received. The main problems that the environmental complex of Cerceda has to face are due to this supersaturation. Therefore, we are working on raising public awareness to reduce the generation of waste and increase the active participation in selective waste collection. At the same time, the new infrastructures provided for the Galician Plan for Management of Urban Waste for the period 2010 to 2020 will enhance relieving the industrial activity of Sogama.